Alrighty. Excuse me. So I am back, ish, or can't be back-ish. I'm all the way back. After, oh wow. Hang on. You know, it looks okay. After hurriedly shoving some food in my face. Okay, I'm just getting set up here. So we actually have our first email submitted questions to go over today, which is exciting. So I'm gonna start out by answering those. But if you have any questions, if you're popping in live, totally hit me with your questions. But in the absence of any live questions, I'm going to start working my way through these email submissions. All right, so first off, all right, so this first example, my display got a little dark. So this first example, oh wait, hang on. Karen has a great question. Ironically enough, I'm looking at your email question right now, so I'm about to get to those too. But the way you show to the power of is you do 10 caret, like 6, or here, make it more manageable, is equal to 10 caret 3 is equal to 1,000. So that caret indicates an exponent. Oh, dude, awesome. All right, so here with this first example, this is actually from the text practice. Oh, it won't let you do a caret, really? I mean, let's see. So answer must be a number. Remove any weird. Hang on. I mean, the worst case scenario is just type the whole thing out. Let's see. Karen, as I'm looking at some canvas stuff, I'm trying to see if there's a way. Okay, here. I think. Okay, Karenessa, I think I've got a workaround. Here, let me actually. So for canvas, it looks like if okay. If this, and this is coming off of the Canvas blog, if this Canvas blog is to be believed, you can enter exponents of 10 like the following. So, for example, let's say we've got 43,000, right? Well, we could write this in scientific notation. Decimals right here, right? Bouncing at 1, 2, 3, 4 spaces over. So in scientific notation, this would be 4.3 times 10 to the 4th, right? Well, you could enter this in Canvas using the following notation. If you go 4.3, and then instead of writing in this times 10 to the 4th, do no spaces, lowercase e, and then 4. And this is equal to 4.3 times 10 to the 4th. So Karen, so that's the other workaround that I've seen on the Canvas blog. Okay, sorry, I'm slowly working my way through the comments here. Susan, working off on lab 1. I calculated 8.54 long. Need to get 2 sig figs. Okay, excellent. All right, Susan. Hopefully for the caret thing, you see what's on the screen at this moment. This should be your way out or your way forward with this E notation. Oops. You can't do letter. Will it not accept them? Okay. Yeah, Karen, as a worst case scenario, just type out all the numbers. Okay. Oh, okay. Kate, I will get to your question in a second. Just Susan got up in the comments first, so give me 1 second, then I'll circle back around. Okay, so Susan, whenever you're rounding, you only look 1 digit over. All right. So if you have, oops. If you have 8.54539,683, and you need 3 sig figs, you go 1, 2, 3. Oh, sorry, you need 2 sig figs. You go 1, 2, and then you look just. I'm going to pick a different color here. You just look at the 4 by itself. And because 4 rounds down, it doesn't even matter if it's followed by a 9. 4 rounds down, so the correct value with 2 sig figs would be 8.5. All right. Okay, so let's see. Are the homeworks supposed to have a time limit? Okay, so Kate, first off, I just got your email in between lecture and lab is when I saw it for the first time. The homework should not have a time limit. Something you should be aware of is lab quizzes do have time limits, but homeworks do not. And just to let you, if Canvas boots you off for running out of time, just email me and I will let you back in. Because the homeworks do not have a time limit. Interesting. Okay, Kate, Susan, you ran into that too, where it was like, here's a timer, but then nothing happened. Yeah, even if it does, then let me know if it boots you off for whatever reason. I'll reopen it. Okay, and okay, so Kate, for the labs. So you find the labs under pages, then you select, I want to make sure I got the right name for things. So you select pages, and then you select view all pages. And then in that will be a list of the available pages, and And right now, lab 1+2 and lab 3 are available. So Kate, go ahead and hit that up. Pages, view all pages, and then you'll see, because when you click pages, you'll just see the home page. But when you click view all pages, you'll see lab experiment 1+2 and lab experiment 3. Let's see, can't find the video. Okay, yeah, and the videos are located on the individual lab pages under labs 1+2 and then lab 3. Okay, awesome. Kate, I'm glad you found it. Okay, let's see. Brianna, on question 16 for the homework, a bit confused on where to start. Do you think you gave an example problem? I totally can. First, let me look up question 16, because I don't remember what it is off the top of my head. Okay, sweet. This actually relates to stuff we did today. So here's a 16 an example like 16 that says basically solve and apply the rules for sig figs. All right, and so I'm not gonna do the exact numbers, but I'm just gonna change the numbers. Let's do 4.7 times 10 to the 4th parentheses times 3.6 times 10 to the negative 5 divided by 9.8 times 10 to the 6th. All right, so here we've got some math to do, right? And because we only have multiplication and division present in this problem, we can do this in any order. You don't have to worry about order of operations here, because we're not switching between multiplication, division, and addition, subtraction. So I'm going to start by I'm going to use a little algebraic trick that I find it makes things easier. I'm going to separate out my powers of 10 and my numbers, all right? So this is going to be equal to 4.7 times 3.6 divided by 9.8 times, and then all the powers of 10. 10 to the 4th times 10 to the negative 5th divided by 10 to the 6th. All right, and when I do 4.7 times 3.6 divided by 9.8, this comes out to 1.7265361, quite a long number. And then when I do 10 to the 4th times 10 to the negative 5th divided by 10 to the 6th, that comes out to be 10 to the negative 7th. So this part right here is there, and this part right here is there. Now when it comes to the number of sig figs, our first number has 2, second number has 2, third number has 2. I can only have 2 significant digits in this number. So it'll come out to be 1.7 times 10 to the negative 7th. So that's how you tackle a problem. Brianna, like question 16 on the homework. It's just mathematical operations while applying the rules for sig figs, and in this case, because everything is multiplication and division, you can do them in any order. I find it easier to separate out the powers of 10, but you don't have to. You could just plug the whole thing into a calculator. The one thing that I want to mention is if you're using a graphing calculator, make sure that you put a big parentheses around everything in the numerator. Actually, in this case, it won't matter, but if you had addition, subtraction, you'd have to keep track of that. All right, hopefully that clears things up. Brianna, let me know if it doesn't make sense. Okay, Esther. Hey there. Okay, for lab 2, how do we identify the letter of the unknown salt solutions? Do not recall any letters given in the video. Okay, let me pull some stuff up for context. Let's see. Awesome. Awesome. All right, let's see. Okay, let's see. Esther, your question is lab 2. Let's take a look. One of the last lab questions. Okay. All right, let's see. Student performs. Okay. I'm seeing it. Let me. Right, because I know in the experiment. The in-person experiment, we'd give you an unknown solution, and then you'd use the graph that you made to find the density of that unknown solution. Let me just take a look here. let's see. %. Ah. Okay, so here. Let's see. I'm actually going to open up a thing. So, so Esther, for lab exercise 2 on that lab exercise 2 page 2.3 you're asking about the place where it says identifying letter of unknown salt solution and then it says percent salt in your solution or your unknown solution. All right. So this one, you can forget. Because in the video they don't do multiple salt solutions; they just do the one unknown salt solution. So you don't have to. They didn't do like A, B, C, etc. And then for this one, you determine this with the density of the unknown and your graph. So you don't have to worry about writing down the letter because they don't do any. They just have an unknown, and then so all you have to do is use your graph and the density of the unknown solution based on the measurements from the video to find the percent mass of salt in your solution. And it's the if you're wondering where they take the measurements, it's lab exercise 2. They start doing this part at 7 minutes and 34 seconds on the lab video 2. So that's where you can find that information. Okay, Karenessa. Lab 1 part B, it says to record the number on the end of the metal object. I don't see a number. The metals are aluminum object and a brass object. Okay, let's see. Lab 1 part B. Okay, let's see. Should the percent... honestly, With the lab 2 question, I don't actually know. Mostly because I haven't run through the calculations myself. Okay, let's see. Hop back a little bit. Okay, lab 1 part.
Hi everybody, this
All right, let's see.
first thing we're going to do is go ahead and get a mass of every single one of these metal cylinders. You are going to choose 2 of these cylinders. It doesn't matter which 2, just as long as they're 2 different ones. All right? So, we're going to go ahead and weigh the aluminum one first.
Oh my gosh. Well, there we go.
And you'll note what the mass is there. Weigh the aluminum one first.
Okay, hang on.
Mass 1. So we'll start with the aluminum, and when you...
Yeah, okay, so, sorry, let's see. Okay, Karenessa, lab 1, part B, it says record. Ba-dum. So, So, Karenessa and Brianna. Lab 1, Part B. Starts at 1730. Okay, so Karenessa and Brianna, Lab 1 Part B starts in the video, 17 minutes, 30 seconds. They totally show the mass of the metal objects followed by the volumes by difference. Okay. That's awesome. Susan, congratulations on locating your carrot. Lab 2, on the graph, should your density for the unknown fall between the other densities? I believe it should. Oh, let me see. I believe, let me be a little more specific. All right, Kate, let's see. May you please guide us through an example, much like question 7 on the homework? Heck yeah. One second. Oh my gosh, Brianna, you're killing me with those cat emojis. They're so good. Okay, something like Kate, you said question 7 on the homework. Oh yes. Okay, and this actually okay, Karen said it has a place to answer the number. Sorry, I'm having a hard time understanding. Let's see. Oh, okay. Oh, so okay. Sorry, Karen. Now I'm tracking with you. Okay. Now I gotcha. Okay. Okay, so totally ignore the where it literally says number on end of metal. Totally ignore that part. Just do the density calculation. In the original lab, so Karen said the reason why that's there, in the original lab, we didn't tell you, in the in-person lab, we didn't tell you what the metal objects were. We just had you write down the number and calculate the density, and then I had a key, and I would look up to see, like, oh, how are your skills? Did you do it right? Did you get the correct density for what your metal object was? But that part didn't translate over into the digital lab, so just ignore that that part. Okay. All right. Now, sorry. Circling back to Kate, you wanted something similar to. Okay. This is a really cool problem. So, based on the symbolic The symbolic chemical reactions given. Ba-dum-ba-dum. Categorize each as a compound, element, or ambiguous. All right, and let me whip up a couple things here. How about we go with a reaction where A is going to C plus B, and then let's see these. D is going to E plus F, and G plus H goes to I. All right. So okay, this problem is very similar to the problem number 7 in the homework. So we need to identify if these are compounds, elements, or ambiguous, if there's no way to tell. Okay, so let's break this down. So here's the thing. If there's so let's talk about this. If you have a reaction where one thing breaks down into two or more things, that tells you that this one thing is a compound. All right? But these two things or more things could be compounds or elements. It's ambiguous. All right, and here's how. So, for example, you could have a reaction where hydrogen peroxide decomposes, so this is a compound, decomposes into hydrogen gas plus oxygen gas. Both of these are elements. All right? So, if you have something breaking down into two things, in this case, the one compound breaks down into two elements. You could also have a reaction where hydrogen peroxide, for example, breaks down into water plus oxygen. And here, oxygen is an element, but water is a compound, all right? So when you have one thing breaking down into multiple things, it doesn't tell you about the pieces it breaks into. Those could be compounds or elements, but the fact that you started with one thing and it broke into multiples tells you that that one thing you started with was a compound. All right? So when you take this logic back and you look at these three reactions, it tells you, first off, that A is a compound, D is a compound, but C plus B and E plus F are ambiguous. All right? Now, in addition, hang on, let me get my... In addition, if you have a reaction where two or more things combine to make one thing, you know that that one thing is a compound. But the two or more things are ambiguous. They could be two elements coming together, they could be an element and a compound coming together, or two compounds coming together. So again, when you have multiple things becoming one big thing... Oh wait, hang on. The multiple things aren't ambiguous. They could be anything. Are ambiguous. They could be anything. But the one thing that they're turning into, you know that that's a compound. And when you look at that fourth reaction, you've got two things. They could both be elements. One could be an element, one could be a compound, or they both could be compounds. But they become one thing. So that is, we know that I is a compound. G and H could be elements or compounds, but I definitely is a compound because it's made up of multiple things. So hopefully that, Kate, shines a little bit of light on how, if you take that logic and apply it to problem 7, that is how you'll be able to sort everything out. Okay, I've got a little bit of a backlog here. Let's see. All right, let me scoot back up, or I'll just leave that there for now. Okay, Karenessa, you asked a question. Here we go. Okay. Also, for Lab 1 under Part 2 for temperature, number 1. Okay, Kate, awesome. I'm so glad. Kate V, I guess. Okay. Okay, sorry, I'm back up to Karenessa's, the one with the emoji. Okay. Lab 1 under Part 2 for temperature. Let me pull that back up. Lab 1, Part 2 for temperature. Okay. Oh, right. Okay, so Karenessa. And this is your... from the way back. Yeah, they did things out of order in the video. Okay, Okay, oh! Brianna, yeah, totally. Okay, let's see. Susan, to round 3,120 to 3 sig figs. Okay. Hang on. Doot. Okay, Susan, I'm finally getting to this question. This office hours is live and hopping. It's awesome. All right. So if you wanted to round, no. Let's open a new tab. So if we wanted to round to 3 sig figs, turns out that this number only has 3 sig figs. So 3,120 with 3 sig figs is 3,120. If you wanted to do 2 sig figs, then you count off 1, 2, and the answer would be 3,100. Let's see. Does that make sense? Yeah. Kate, you're spot on. 3,120 totally works because that last zero is not significant. Yep. Totally. Okay. Okay, let's see. Okay, awesome. Yep. Okay. Wow. Currently, let's see. Okay, Carolyn. Let's see. Could I get some help on how to find the percentages of salt? Ah, yes. No. Your question, Carolyn. Your question totally makes sense. Okay. So here's the deal. I am going to make something up here. So these numbers totally won't correspond to anything real, but this is how you solve it. All right. So Carolyn, to determine the mass percent of sodium chloride in the unknown, you need 2 things. You need the density of the unknown, and you need your graph of all the other things. Okay, now for this problem, I'm going to make up a graph. So I'm just going to make one up. All right, so we've got y, we've got x. The y is the, whoa, that was a giant eraser. Yeah, there we go. The y, we put density, percent sodium chloride on the x-axis, and we plot our points. We make our graph. I would recommend doing it in Excel, but don't have to do it in Excel. But here's the reason why I like Excel, is it gives you an equation of a line. Now, let me just see here. Who cares? To do this, so you need your density of your unknown, all right, and you need your graph, because the graph gives you your equation of the line. Y equals mx plus b. All right, now your density is your value for y, and your percent mass of sodium chloride is your value for x. All right, so Carolyn, what you have to do is, you know the density of the unknown, and when you make your graph, you can figure out here you know that B is your intercept and M is your rise over your run, right? That's M. So from your graph, you know M, you know B. Oops. So now you can solve for X, right? Because we plug in the density for Y is equal to Mx is your percent sodium chloride plus B. So we're going to start by subtracting B from both sides. This will give us density minus B is equal to mass times X, which is your percent sodium chloride. And then we divide both sides by our slope, and we get X is equal to the density of the unknown minus the intercept of your graph divided by the slope, or the SOAP, I guess, the slope of your graph, and this will be equal to the percent sodium chloride. So Carolyn, that is how you determine the mass percent of your unknown. Okay. Oh, and it looks like in the time I solved that problem, I started getting buried in the comments again. Let's see. Okay, so Susan, 2.544 centimeters and 1 inch. Okay. Okay, so 2.54 centimeters is equal to 1 inch. So Susan, so check this out. The 1 inch, the 1 is exact. But the 2.54, this is measured. Because this is exact, it means that it has unlimited sig figs. Because the 2.54 is measured, it counts. This only has 3 sig figs. So when you use this unit conversion, you will be limited to 3 significant figures. Yes, Brianna, you are totally correct. This unit conversion is not exact because, and this is the big thing to remember, whenever you convert from one system to another, the unit conversion is measured. In other words, inexact. Unit conversions are only exact when you stay within the system. That is, Brianna, that is correct. That is totally correct. If something is measured, it's inexact. Okay, and this is good. This is good. I'm really glad we're having this discussion. Here's the thing to remember. There's 2 types of quantities that we'll be interacting with. There are measured quantities. If something is measured, that means it's inexact. Which means we've got to deal with sig figs. If a number is based on a definition, if something is defined, it's exact. Which means we got no sig figs. So, for example, 1 foot is 12 inches. This is based on a definition. Not a measurement. It's not like someone got a foot and was like, how many inches are in this foot? Let's measure how many inches are inside this foot. It was defined. 1 foot is defined as 12 inches and vice versa. So it's based on a definition, not a measurement, which makes it exact. Does that make sense? Okay. Hopefully that clears things up a little bit. Okay. Okay, so let's see. Also, kind of a bigger thing to mention, ask about, but on the pre-exam. Yes. Okay. Here, let me pull it up. Ba-dum. Oh my gosh, I'm so sorry. I've been saying Karenessa. It's Karensa. I apologize. I've been literally butchering your name for a week, and you have been too kind to say anything. Okay, yeah, so I suspect there are, typos, Kate. Yes, absolutely. Oops. Both. Of course, yeah, totally. If there's a typo, there's no reason you guys should be losing points over a mistake that wasn't yours. So I will totally correct that and make that right. I just haven't had the opportunity to double check things yet, but I will be getting around to it this weekend. Okay, let's see. All right. Karensa. I'm going to try to get your name right from now on. You sent me some questions about homework problems from the book, which was awesome. Here's one. This is this homework, chapter 2, number 21. All right. It says indicate to what decimal position readings should be recorded to the nearest tenth, hundredth, etc. for measurements made with the following devices. So so this is indicate the number of decimals for, and then they give us a list: A, B, and C and D. Yes, totally. This is something that that I firmly believe in. Dude, just a side note, I'm a firm believer that question askers are as important as the instructors, because for each one person who asks a question, there are like at least a third of the class has the same question, but they're just too afraid to vocalize it. So I have no way of knowing what you guys are understanding or struggling with, because I'm not Charles Xavier and I can't read minds. But when someone who asks a question puts that out there, it gives me a chance to explain something that most of the class is struggling with. I just have no way of knowing. So I'm so thankful for students who ask questions. Never, ever stop. Okay, with this one, we need to indicate the decimal places for a thermometer. That has a scale, so to the ones place. So they have a marking every 1 centimeter. A graduated cylinder. With, cylinder. It's a cylinder. I'm a dork. Pirates say cylinder. Graduated cylinder with the smallest markings. So the scale here is 0.1 milliliter. C, volume. Okay, let's talk about the volumetric device. That one's probably the trickiest. All right, and then a ruler. Whose scale is... a ruler whose scale is 1 millimeter. Okay, so Karenessa, this is Karensa. Okay. I'm gonna learn your name. I promise. Karensa. Yeah. I'm so sorry. This is a great question because we learned that when you're making a measurement, you take the scale of whatever device that you're dealing with, and you measure to the uncertain digit, one decimal place, one place beyond the last marking on the unit. So for a thermometer whose scale is to the 1 degree Celsius, we're going to be measuring to the 0.1 degree C. Right? Oh, you are too kind. I'm gonna get better. That is my promise to you. Okay, so the uncertain digit is one place beyond the last scale of the measurement or of the measuring device. So a thermometer that measures to every 1 degree will be recording to the 10th place. For a graduated cylinder who records to the 10th of a milliliter, will be recording to the 0.01 hundredths place, one beyond, right? And I'm going to skip to the end here and say a ruler that measures to 1 millimeters, the 1 millimeter place, that's the scale, will measure to the 10th of a millimeter. All right, now I missed one. Or I didn't miss one. I skipped one. Oh, and apparently I can't spell volumetric. Volumetric device. Now, we haven't encountered these yet. Volumetric devices are instruments that measure one volume. So if you used a 10 milliliter volumetric pipette or flask, it only measures 10 milliliters. It doesn't measure any other volume. All right? Now, that being said, it measures that one volume super accurate. All right? It measures that one volume.
12.
Hold on. It measures that one volume very, very, very accurately, all right? And it always does so to 2 decimal places. So we haven't talked about this in class. You use volumetric glassware fairly frequently in lab. You'll see it in the lab videos. There will be lab videos where we use volumetric flasks or pipettes. A volumetric device means it'll measure that one volume, whatever it is, but to 2 decimal places. All right, so that's something new. You could answer A, B, and D based on what we talked about in class, but we have not talked about volumetric glassware, so that's how you handle that question. Hopefully that makes sense. And please let me know if it doesn't. All right, Carenza, that was your first question you emailed in, and then you sent in a couple more. Okay, let's take a look at these. So 23, consider the following rulers as instruments. What's the following ones? Measured length. Okay. I'm going to try to do something. I don't know if it'll work. Okay. Oh, okay, problem 23. You know what's so funny is okay, so when we look at problem 23, so this is whoa. When we look at chapter 2, number 23, so they give us 3 rulers. You can turn there in your book if you have one, where it's 3 different rulers, 3 different paper clips, and then they ask, so the first one, they ask what would be the uncertainty what would be the uncertainty in measurements made with and then they say, for example, A would be, oh, here, let's color code it. Ruler 1, B, they say ruler 4, oh, they just have us do them all. So the thing is, so for ruler 1, whoa, ruler 2, ruler 3, ruler 4. They ask for all of them. All right, so this comes from looking at the precision of each ruler. So, for example, when you look at ruler 1, ruler 1, they've got markings like so. Oh, here. Let me squish those down just a little bit. So like 1 centimeter, 2 centimeters, 3 centimeters. All right, and again, remember, we're after the uncertainty, and the uncertain digit is 1 beyond the scale of the ruler. So since ruler 1's scale is to the 1 centimeter, the uncertainty is 1 beyond that, right? The uncertainty would be one beyond to 0.1 centimeters. All right. Ruler 2 has, oh, here. Hang on, I'm going to have to get better with my art skills for ruler 2. Ruler 2 has, hang on, 10 markings in between each centimeter. All right, so if this was number 2 and this was number 3, ruler 2 has the markings down to the first decimal place, so its uncertainty would be one space beyond that, right? It'd be 0.01 centimeters would be the uncertainty for ruler 2. Ruler 3 looks like this. Each marking is to the tens, right? So it's 10 centimeters, 20 centimeters. So that means ruler 3's uncertainty, be one beyond that, would be to the ones place, because the last marking on ruler 3 is in the tens place. And then ruler 4, whoa, let's get this back in black. Ruler 4 is very similar to ruler 3. Two, three, 4, 5, 6, 7. Gonna make this ruler a little taller. You can see that ruler 4 is again to the measures out to the ones place. So it would be have uncertainty to the 0.1. So when they're talking about uncertainty in problem 23, they just it's the same thing that we talked about in when we talked about the uncertain digit. Uncertainty is the uncertain digit. It's one beyond the last scaled marking on the ruler. So hopefully that makes sense. I know that explanation took a while. Mostly because it took me a while to draw the rulers. Hopefully that helps clear things up a little bit. All right. And then okay, sweet. Good. I'm so glad. All right, and then actually, the last email, last but not least, the last email questions are actually coming in from Susan. And okay, sweet. I already actually talked about homework 1, problem 7. So we did that one. Okay, homework 15. Okay, let's see. Let me pull up experiment 1. Okay, let's see. Probably somewhere near the end. Yeah, near the end. Let's see.
This has calibrations on here, and if it is floating exactly at 1.000, that means that this urine has the same density as water, because it's equally buoyant. However, urine has dissolved solids in it. It has salts, sugars, and some proteins. Then the number below the level is 1.5, so it's, if you big min here, it's somewhere between 1.4 and 1.5.
Okay, Susan. So with the oops. Okay, so for the hydrometer or hydrometer. So it's, oops. Oh goodness. There we go. So it's this funky little bell-shaped thing, right? And here it's got a bunch of markings. Whoops. We're like right up at the top. Here, hang on.
Yeah, so we would expect that urine.
So, right here at the top of the hydrometer. We've got, this is 1.000, right? And this is a unitless quantity. And then they've got, what does this go to, like 0.6, right? Like down there it says, well, on the hydrometer itself, the way it says it's 10, 20, 30. Here, I'm gonna chop up my drawing just a little bit. All right, here's how you read it. And then in between here, so like if you were to blow up right here and here, it'd be 20. Right, there are like 10 little hatch marks in between every mark on there, between 10, 20, 30, 40, 50, 60. And I know it's confusing, but here, where it says 10 should actually be 1.10. 20 should be 2.20. 30 should be 3. Oh, sorry, not 2.20, 1.20. 30 should be 1.30, etc. All right. And because we're dealing with uncertainty and moving beyond, something that you should know is all measurements let's see, I'm running out of space here. All measurements taken with this hydrometer should have 3 decimals. And you kind of add as you go down. So that's kind of how you want to use it. And I realize that, like, it's hard to see with the meniscus. That meniscus is like kind of big and fat, and it looks like it's somewhere between the 40 and the 50. So because of the decimal situation, your answer for this thing should be somewhere between 1.400 and 1.500, and how exact you get totally depends upon your eyeballs. It's your judgment call, but the answer should be between these values. Wait. Wait, hang on.
In this case, a urinometer. And this has calibrations on here, and if it is floating exactly
Oh.
1.000.
Yeah, hang on. I messed this up. All of these. Sorry, I thought something felt off. All of these should be. We should have the zeros in here. Right, so that means, let me just fix this. There we go. Ah, okay, Brianna, I think I know what your problem was. Yeah, Susan, that looks spot on. Totally spot on. Oh yeah, stay. Oh, let's see. Okay, Carolyn. No worries. B is the So to find B, you have to first make the graph of all the known solutions, and then you make a line that best fits all your data, and where that line crosses the y-axis, that is the value that you need to use for B. Okay. Okay. So, you totally could. So, Carolyn, there's a couple ways to tackle this. You could totally do it in Excel, and Excel would generate that equation of the line for you and tell you what B is. Or the other way to do it is you can plot it out, and you've got 4 data points, right? 1, 2, 3, and 4. And if you physically graph it, then you just make a line like that best fits the data as best as you can see, and you take that value, and that is your B. Or you can plot the known things in Excel, and Excel will tell you what the value for B is because it'll give you the equation of the line. Okay, Brianna, you're still confused on the specific gravity for urine. Not getting the right answer. Okay. Okay, hang on. Sorry, Carolyn. Yeah, you can try platting the line. Maybe I'm from Boston today. You plat, you line, you pack, you ca. I don't know how good or bad that is. The only thing I know about Boston accents is from watching The Departed. Okay, Brianna, let's talk about specific gravity. Okay. Okay, let's see here. So Brianna, we've got this is iron plus cylinder. Well, actually, dude, yes, totally. Carenza, it's totally hard to read. Brianna, what are you getting for the density of urine? Okay, awesome. Awesome, Brianna. That sounds... That's fantastic. That is totally spot on. Yeah, Brianna, it looks like everything's totally fine. You don't have to worry that your calculated specific gravity is possibly different than what was shown on the video using that little hydrometer device, because it's hard to read. It's not going to be exactly the same, just due to errors. There's errors in the measurements that went into your calculation for specific gravity. There's errors in reading the hydrometer. But the point is that they're both ballpark, so I feel totally confident in your calculations. It looks like everything is spot on. Yeah. No. You totally did everything right. Yeah. Let me check, Susan. I think. So use a hydrometer. You know what's funny is it says. Oh, at Carinza, your value looks all right, but totally. Oh. Oh, dude. Hey. Okay, Susan, let me see. Thing of measuring, hydrometer more accurate. Calculating because of Ah. Okay, let's see. Just double check it's okay. Too early. I don't know if you can hear the cries of joy coming from the next room, but I'm pretty sure that's my kid getting some sweet stuff on Animal Crossing. I don't know though. That's my best guess. This mic is pretty good, so it can pick up laughter from one room over. Oh my gosh, yeah, everybody's loving Animal Crossing. I haven't started playing it, mostly because I've been working my butt off for this class. But I don't know, I don't have a ton of time for gaming these days. And so my kids are like, oh, you gotta play Animal Crossing. You gotta play Animal Crossing, you'll love it. But there's a part of me that's like, it's, so I'm like, but when do we battle our Pokemon? I don't know, like, with the precious time that I have for gaming, do I want to try Animal Crossing, or do I want to, like, play Pokemon or Breath of the Wild or something? Every single person who I know who's played Animal Crossing stinking loves it. So there's got to be something there, but I'm a little bit on the fence. Oh my gosh. Totally. Okay, let's see. Okay, Susan has a non Animal Crossing related question. Okay. Susan, yes. Totally. It's a game where you, like, make friends and help them out with stuff, like build houses, and you catch fish, and you can make stuff, like craft stuff. Yes, it's Susan. It's like real life, the game, only relaxing. Um, oh my goodness. You could teach your villagers chemistry. That'd be hilarious. Totally. I guess, like, the real question is, can there be more than one island per console? Because if so... Yes, and we can all show off the fish that we caught. It's funny. So I've got a 12-year-old, a soon-to-be 10-year-old, and a 2-year-old, and my 2-year-old loves whenever whoever's in Animal Crossing, whether it's my son or my daughter playing. My 2-year-old loves when they put their fish on display. He'll be like, burr, 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 and it shows the fish. And when someone's playing it on the TV and the 2-year-old walks by, he's always like, fish, more fish, more fish, until someone puts their fish on display, and then he claps. Carolyn, yeah. So I'd have to play on one of my kids' islands. My we had a Switch, but then my daughter was saving up her dollar bills and decided to get a light, so they each have their own island. But it sounds like I would have to get my own Switch if I wanted to have my own island. Oh well. I'll have to stick with Pokemon and Breath of the Wild. Excuse me. It is pretty cute. It is pretty cute. He's the 2-year-old is in Animal Land right now. He's all about pointing out dogs and cats and fishes. Dab and a fish. That's pure fire right there. Oh my gosh, yes. Yeah, Breath of the Wild is incredible. We all can't wait for the sequel. The irony is, between me, my 12-year-old and soon to be 10-year-old, I'm the only one who hasn't beaten it. They've all made it to Ganon and done all that stuff. I haven't yet. Oh, let's see. Real question, Susan. What's the lab? Oh, does not matter. Yeah, Studio Ghibli is totally where it's at. That's the one I would have voted in the syllabus quiz, if you were wondering. Let's see. Susan, great question. So it turns out 1 milliliter is equal to 1 cubic centimeter. So those two units are the same. Yes. Totally solid. It is all good. Oh. Let's see. Yep. Totally okay. Of course. All the volumes. Oh, no, Carolyn, not a big question at all. Um, Oh. Let's see. Number 2. Oh yeah. Hey man, but you're learning to catch it, right? Heck yeah. let's see. Of course. Oops. Ah, Kate, great question. Great question. Hopefully that makes sense. Let me know if it does not. They'll be back soon. I'll be done soon.
I got 5.5 hours.
Well, what?
Right now. So I have 3.5 hours.
Solid.
So I can eat my daddy for 2 extra hours.
That's awesome.
But tomorrow, I'm going to
Beautiful. So you just gotta wait till midnight.
well, no, after that, right now.
Oh,
So it doesn't
solid. Solid. Cool beans. Alrighty. So I just saw that we are just about out of time. Are there any last questions before we peace? If not, then I'm going to go ahead and call it a day at this moment in time. It's been an awesome office hours, plenty of questions, lots of good stuff. And yeah, this is the last class of week 1. I hope you all have an awesome weekend, study hard, and I will catch you on Monday. Later.